Earlier in the program, we looked at some of the forces that are exerted by conductors. The forces we looked at included weight, line tension, and bisect tension. We saw that bisect tension is the pulling force exerted by a conductor as it tries to pull the corner pole into line with its adjacent structures. We also looked at how bisect tension can be determined by making certain measurements. In this part of the program, we'll look at two additional methods you can use to determine bisect tension. After that, we'll look at how guying is used to offset line tension and bisect tension. We'll also look at how guy tension can be determined and some of the safety factors that should be considered in guying and other rigging. Now, the first method we'll look at to determine bisect tension uses a bisect tension formula. The second method involves finding the approximate angle of the line at the corner pole and then using a rule of thumb chart to estimate the bisect tension. Both of these methods require the same measurements to be made at a corner pole or structure. Let's take a look. This is an overhead view of a corner pole and two spans of conductor. The first step is to extend a line from the corner pole, which is labeled A, 50 feet in the direction of the conductor if it continued in a straight line instead of turning at an angle. The end of this line is labeled point B. Next, measure 50 feet in line with the actual conductor. This point is labeled point C. The distance of 50 feet is a constant that has been worked out mathematically for this method. Now, the distance from point B to point C is measured. In this example, the distance is 64 feet. This distance gives you the approximate length of the bisect line and can also be related to a chart to determine the approximate line angle. This chart lists different lengths for the line BC and the line angle associated with each length. For example, in this case, the measurement from B to C is 64 feet. So the line angle is approximately 80 degrees. It's important to remember that this method is for approximating the length of the bisect line and the line angle. We'll see how to use the line angle in a moment, but for now, let's continue by using the formula to determine the bisect tension. Bisect tension equals line tension, which you'll recall from the last part of the program is 853 pounds, divided by 100, times the length of the bisect line, which is 64, times 2. 853 divided by 100 equals 8.53. 8.53 times 64 times 2 equals 1,092 when rounded off. So there is 1,092 pounds of bisect tension exerted by the conductor on the corner pole. So in this example, we saw how to find the approximate length of the bisect line. Then, by using a formula, we determined that the bisect tension is approximately 1,092 pounds. Another way to determine the approximate bisect tension is by following a rule of thumb chart. Let's take a look at a chart to see how it works. This chart lists 6 common line angles. After each line angle is an equal sign and a decimal number. To use this chart, both the line angle and the line tension must be known. In some cases, you can determine the line angle by using the line angle chart we looked at earlier. After you have these figures, locate the line angle on the chart. Then multiply the line tension by the decimal number that follows the equal sign, and the result is the approximate bisect tension. For example, the chart shows that for a 90-degree line angle, the bisect tension is approximately equal to 1.5 times the line tension. If the line tension is 853 pounds, 1.5 is multiplied by 853 to give a bisect tension figure of 1,279.5 pounds. If the line angle is 45 degrees and the line tension is 853 pounds, 853 is multiplied by 0.75 to get a bisect tension figure of approximately 639.75 pounds. Bisect tension and line tension are important to know when you're planning a job. They're also important to know in order to guy a pole or structure against the forces exerted against it. Now, this is accomplished by placing guy wires on the structure to counteract line or bisect tension. The tension exerted by guy wires to offset line tension or bisect tension is sometimes referred to as guy tension. One way to determine the guy tension required is to use a formula. The formula reads guy tension equals bisect tension or line tension divided by anchor distance times guy length. Earlier, we determined that the bisect tension in this example is 1,092 pounds. Let's suppose an anchor is installed 30 feet from the base of the pole. Now we have two of the values we need to fill in the formula, bisect tension and anchor distance. But what about the third value, guy length? One way to determine guy length is to make a scale drawing. For example, this line represents the height of the conductor above the ground, which in this case we'll say is 50 feet. In this illustration, we'll say that an inch equals 10 feet, so this line is 5 inches long. This line represents the distance from the butt of the pole to the anchor, which is 30 feet. Using the same scale, this line is drawn 3 inches long. All that remains is to measure the length of the line that represents the guy wire. Assuming the guy wire is backing up the conductor, and by using the same scale, the line turns out to be 5 and 15/16 inches long, which represents 59 feet after rounding off. Now we have all the values needed to determine the guy tension. Let's use them in the formula. Guy tension equals bisect tension, which is 1,092, divided by anchor distance, which is 30 feet, times the guy length, which is 59 feet. Working through the math, we determined that guy tension is equal to 2,148 pounds when rounded off. So it takes approximately 2,148 pounds of guy tension to offset 1,092 pounds of bisect tension when the guy is anchored 30 feet from the pole and the conductor is 50 feet above the ground. Now, the same formula can also be used to determine the guy tension at a dead-end pole. This is done by substituting line tension for bisect tension in the formula. An important factor to remember is that the guy tension required to hold a pole or structure in place will decrease as the distance between the pole and anchor increases. The guy tension will increase as the distance between the anchor and the pole decreases.